Okay, Algebra 2 fans, our topic for today is geometric sequences and series. And before we start this, let me read you your joke of the day. Why do chicken coops have two doors? The answer, because if they had four, they would be chicken sedans. All right, so the goals for today, we're going to find the nth term of a geometric sequence. We're going to find the sums of geometric series and infinite series. I'll add that in there, and use sigma notation to express sums. But the first thing we'll do is we'll do a little bit of a review of arithmetic sequences and series. Arithmetic means that when you look at the numbers, when you look at the sequence, you are adding or subtracting the same number each time to get the next term. So for the sequence 4, 11 halves, 7, 17 halves. Now, it may be a little difficult to see the pattern, so what we can do is write this as decimals. So 11 over 2 is 5.5, and then we have 7, and 17 over 2 is 8.5. So we have 4, comma, 5.5, comma, 7, comma, 8.5. So you look at that, and what's happening is we are adding 1.5 every time. So we will say that D, which is the common difference, okay, so the common difference, D, is equal to 1.5 or 3 halves. It's really up to you if you want to use the fraction or the decimal. In this case, I'll actually use both. Okay, so for part A, find the 10th term in the sequence. Well, we have a formula for that. I'm going to write it actually up at the top here. So a sub n equals a sub 1 plus parentheses n minus 1 times d. A sub n is the nth term, that's the last term that you're trying to find. A sub 1 is the first term, and then n is the number of terms, and d is the common difference. Okay, so that's for finding the nth term. Also, I'm going to write down the formula for the sum of an arithmetic series. It's n over 2. So the sum of the first n terms is n over 2, n is the number of numbers, times a sub 1 plus a sub n. Okay, and again, I'll write it down for this one. A sub 1 is the first term. A sub n is the last term. N is the number of terms. Okay, n is the number of terms. And in the first formula, the other thing was d. That is the common difference. And it can be positive or negative. Okay, the difference can be positive or negative. All right, so here we go. For number 1, part A, find the 10th term in the sequence. So I'm going to use the formula a sub n equals a sub 1 plus parentheses n minus 1 times d. In this case, n is going to be 10. Okay, so we're looking for a sub 10, that's the 10th term. That is equal to a sub 1 is the first term. That was 4, plus n minus 1, that's 10 minus 1 in parentheses, times d, which is the common difference. That would be 3 halves. I'll write it as the fraction. And then what we do is we work this out. So this would be 4 plus 10 minus 1 is 9, so it's 9 times 3 halves, which is 4 plus, that will be 27 over 2, and then if you get a common denominator, that's 8 over 2, so plus 27 over 2 equals 35 over 2, or 17.5. And you can certainly type this into a calculator and get the same values for that. Okay, so I'm going to go through the computation a little bit quickly, but you can use the calculator. Find a sub 103. So find the 103rd term. So a sub 103 equals, the first term is 4, plus n minus 1, that would be 103 minus 1, times the difference, which is 3 halves. So again, we'll simplify. We get 4 plus. I subtract 103 minus 1, we get 102 times 3 halves. Now I can do, this is 4 plus, I can simplify 102 divided by 2 is 51. 51 times 3 is 153. Add that to 4 and we get 157. Okay, so that one actually works out to an integer. Again, if you want to, you can take a calculator, and I could have typed the original expression, 4 plus parentheses 103 minus 1, and then times 3/2. I like to put my fractions in parentheses when I type it, but you don't need to. Equals 157. Okay, so there we go. Now, part C says find the sum, S sub 103. All right, so S sub n, the sum of the first n terms is n over 2 times the first term a sub 1 plus the last term a sub n. Now, in this case, we're going to find S sub 103. N is the number of numbers. We're finding the 103rd, the sum of the first 103, over 2 times the first term 4 plus the last term a sub 103. We just found it. It's 157. So it's 4 plus 157. And then we're going to simplify from there. So that's 103 over 2 times 161. And when you work that out, okay, this time I will just write it as a decimal. It's going to be 8,291.5. You can check me on the arithmetic. 8,291.5. Now, number 2, which is also a review, this is called summation notation. That means we're going to be adding terms together. 4n minus 3 is the function that we're going to use. And we're going to substitute the values 1 for n, starting with 1 and ending with 5. So what this will look like, we're going to do 4 times n minus 3. That's the first term. Okay, plus, now the second term, I plugged in a 1. Now I'm going to plug in a 2. So I'm going to go 1, and then 2, 3, 4. I plug in 5, and I stop. So I'll do 4 times 2 minus 3. That's the second term. And then 4 times 3 minus 3. Plus 4 times 4 minus 3. Plus 4 times 5 minus 3. Now I stop when I get to 5. So when you see this, the bottom number 1, that's where you start. That's what you plug in first, and then you just keep going up one integer at a time until you get to 5. You plug that in, and you stop. Okay, so I'm going to work this out. The first term, that would be 4 minus 3, which is 1. And then 4 times 2 is 8 minus 3. The second term is 5. The third term would be 12 minus 3, which is 9. You start to see a pattern here. Notice that we're increasing by 4 every time. And what happens? The next term is 13. The last term is 17. And if we add all those up, we get 45. So this is the same thing as what we did in part C. We're just looking at it in a different way. Okay, we're adding up all the terms in that series. So that's a review of arithmetic. Okay, so let's talk about geometric, which is a little bit different. In arithmetic, you're going to be adding every time to get the next term. Now, geometric, here's an example for you. 2, 4, 8, 16. Now notice we're not adding the same number every time. Now we're multiplying. We're doubling it. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And if we continue with this pattern, 16 times 2 is 32. And then 64. And then 128. This is what we call a geometric sequence. It's a sequence where each term after the first is found by multiplying. Not adding or subtracting like arithmetic. We are multiplying the previous term by a constant called the common ratio. Common ratio. We're going to use the letter R for that, the common ratio. So in the example that we just did here, the common ratio is 2. To get the next term, you take the previous term, multiply by 2. Now the ratio this time we are going up, the numbers are getting bigger. It can also go down, so that is a possibility. So let's look at number 3. Find the next 3 terms in each geometric sequence. So again, geometric means that you are multiplying to get to the next number. So 4 to 16, 16 to 64. If you know it's geometric, or if they tell you it is, if you want to find the ratio, take 2 numbers. So take 4 and 16. Divide them. Okay, take the second number divided by the first. 16 divided by 4 is 4. That's my common ratio. So 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. And then 1024, and then 4096. And on the side, let's write down R equals 4. That's the common ratio, the number you multiply by each time to get the next term. Now part B, 81, 27, 9. Notice that we're going down. So we're not, you could almost think of this as you are dividing, but I'm going to think of this geometric, I'll always think of it as multiplication. Okay, so to get from 81 to 27, what I'll do is I'll take 2 terms, and I will take the second one divided by the first. What I get is 1/3. So now, what we're doing in this problem, we are multiplying everything by 1/3. 81 times 1/3 is 27. 27 times 1/3 is 9. 9 times 1/3. You can think of it as dividing by 3. Okay, 9 divided by 3 is 3. 3 divided by 3 is 1. And we keep going. 1 divided by 3 is 1/3. If we went one more, 1/3 divided by 3 is 1/9, 1/9, and so on and so on. The common ratio is 1/3. So if you want to think about it in terms of division, you can. But in terms of the ratio, it's about what you're multiplying by. It's the number that you multiply by. The common ratio is 1/3. And so that's the end of the front. We'll go ahead and stop right there. That's the end of part 1. Go ahead and flip it over and we'll start part 2.